So 1.5, rotation today. And we've already talked about, what was the other one we talked about last week? Translation. And what's the third one we still have to focus on after this? Reflection. So translation, rotation, and reflection are all forms of what? Transformations, okay? And they're all rigid motions, okay? So a rotation is a rigid motion that moves a figure along a circular path about a fixed point called the center of rotation. That is important to know because they're going to give you different centers of rotation. When we start off, it's going to be easy. Most of the time it's going to be the origin. 0, 0 is my center of rotation. Okay, so it would be like I put a string here and then I rotate it about that. Okay, or like on a spinner, when you play board games or something, how they have spinners, the center of rotation is like the center of that spinner. Okay, same concept for applying it to shapes. So you have to pay attention to where the center of rotation is, because it could be a point. They could say the center of rotation is -2, 1, which means this would never change where it's at, only the other 2 points would change. Okay? So you have to pay attention to what it tells you. Okay? An angle of rotation, because rotation happens with angles, not just with other things, but anytime I create a rotation, I've created an angle. Okay? You're going to pretend like a string is drawn from the center of rotation out to your original shape, and then from the center of rotation to your mapped shape. Okay, that is the angle of rotation, where it opens up or where it opens down. That's considered by angle of rotation. It's defined by 2 rays, okay? 1, 2. One ray goes from the center of rotation to the starting point on the first figure, and the other ray goes from the center of rotation to the corresponding final point on that figure. So to that mapped point, or to that redrawn shape, okay? So here in this purple and in the brown, I have examples of these, okay? I'm going to actually use a different color here. So this right here is my original shape. Why do I know that this is my original shape? Because there's no dash marks, there's no hashtag or little hash marks to tell me. So that's my original shape. Now, my original shape, point B is at -2, 1, point A is at -6, 1, point C is at -6, 3. Okay? This here is my new shape. After I did an angle of rotation, after I did rotation on it, that is my new shape. The reason I know is because of these little tick marks. Okay? And the new points end up at 1, 2, 3, 6, and 1, 6. Okay? I want you to think about these points for a minute. Okay? Do you see right here all these points? Tell me what you can see in common. Point B originally was at -2, 1. Now it's at 1, 2. What happened there? What, Carly? What do you notice? Okay, the X and Y switch places. What else happened? The X and Y switch, what else, Doug? Okay, the points are both positive. Were the points both positive or both negative over here? No, one is negative, one is positive. So more specifically, X and Y switch points, but also the Y became opposite of what it was. Okay? Here I have -6, 1. I go to 1, 6. X and Y switch points, and the Y became opposite of what it was, or the X became opposite of what it was. Here I have, what do I have? -6, 3, and I go 3, 6. X and Y switched, and X became opposite of what it was. Okay. Here is my point of rotation, or my angle, my point of rotation happens about the origin. When I draw a line from point B to mapped point B, this creates a what type of angle? If it has a box like that, what type of angle does it have? A what? 90, a right angle, a 90-degree angle. So it is rotating 90 degrees clockwise. When you rotate 90 degrees clockwise, you reverse the coordinates and take the opposite of the new y coordinate. So X and Y switch, okay? and this becomes opposite. So it's just a rule. So you can technically do it in your head. Does that make sense? You can technically do it without even graphing it. Okay, 90 degrees clockwise, X and Y switch. X becomes opposite of what it was. Okay? When you do counterclockwise, X and Y still switch, but Y becomes opposite. Okay, here X becomes opposite, Y becomes opposite. We're going to play around with it. We can play with it on your computer too, okay, at that website that we're going to talk about in a little bit. In the brown, I have another example. This one rotated clockwise, okay? You guys know which way a clock turns, yes, even though everything's digital in your life. Okay, so this rotated clockwise, that's how we decide what the angle of rotation is, which direction it's heading in. We can measure the angle of rotation, okay? Here, I have a new one, a new shape, okay? What is going on here? Which one is my original figure? The one in quadrant 2 or the one in quadrant 4? What? The one in quadrant 2. One in quadrant 2 is my original shape. I have regular A, B, and C. I don't have my little tick mark. That tells me this is the new mapped image. This is having rotation. This arrow shows me that it's rotation. Okay. It tells me it's counterclockwise by 150 degrees. Okay, so this angle rotates 150 degrees. Each of those points rotate 150 degrees. Okay? This original point here is at negative 2, 1. This is at negative 6, 1, negative 6, 3. Okay? Here, this is like in between 1 and 2. So when I have 150 degrees counterclockwise, I don't have a specific rule I can follow. Okay? 90 and 180 are going to be where we have rules that we follow that make it easier. Okay? Otherwise, we just have to measure and figure out how much that angle of rotation was. Okay? So once again, this is just showing you an example of how we can rotate an item, an object. Okay? Use a little bit of common sense. If something starts in quadrant 2 and it's rotating 150, I know it's going to end up in 4 if it's rotating counterclockwise because this is 90 degrees. This is another 90. So it's more than 90, but less than 180. You get what I'm saying? Okay, so you're going to use some common sense here. So if I rotate something by 720 degrees, how many times have I rotated it technically? 720 degrees. Yeah, twice, because 360 is a whole circle, right? And 360 twice means it's going to come right back to where it is. So that object would rotate on top of itself. Okay? But it would have rotated around 2 whole times. So you gotta start thinking that way a little bit. Okay? Okay, get out your computers real quick. And go to that amscomath.com that we've been going to. amscomath.com. Okay, and you're going to go to lesson 1.5, rotation, segment rotation, rotation, angle rotation. Okay, so the first one is rotation with a segment. So it just shows you 2 points, and you can tell it how far you want it to rotate, the coordinates that you want it to end at. If you go back into the one that says, rotation, angle rotation, that is going to give you an actual angle, and you have to rotate 3 points. And then the final one is a shape rotation, and I believe it's a triangle they give you. Okay? Yes, it is. It's like a little fat policeman or something, and it's shaped like a triangle. So on your homework tonight, okay, if you need help with that, you can play with those numbers. You can put in all the original points and then tell me what you're rotating it by. You can also do it if it's 90 or 180 with the rules that we have, which I'll make a chart for you in just a minute. That will be easier than just those rules that way. Okay? I'm better at just plugging it in and doing it, memorizing the rules and going. Some people are better at visualization. So either what can work for you tonight. Does that make sense? Okay. Has that been helping you a little that side at night, some of you? Okay. Good. Okay, so let's just look at a couple of examples. We need to talk about word problems with rotation, okay? You're going to pretend this is a wheel because that's about as good as it gets with my drawing of a wheel, okay? It says, using the wheel's center as the center of rotation, which makes sense on a wheel. The center of rotation would be the center of the wheel, okay? It says, what is the angle of rotation from A to B? So here's my wheel. They want to know, how can I get A to B? What is that angle of rotation? Okay? Now, let's talk through some scenarios. What do we know about a wheel? What shape is it? A circle. How many degrees total are there in a circle? 360. 360. How many portions is this circle divided into? Okay. 6. 1, 2, 3, 4, 5, 6. So what do you think I need to do to figure out how I get A to B and figure out what this angle of rotation is here? What? Okay, I got to figure out which each individual angle is. So if I can figure out what the angle of this little triangle is here, then I can multiply that by however many I need to figure out what that angle of rotation is. So there are 6 parts, which means I need to divide this by, and you would get what? How much is each angle? 60 degrees, right? Each angle is 60 degrees. Okay. How many angles does that go through? Okay, there are 6 total, but how many? Yes, Korea. I want to know how many angles this makes up. 1, 2. So that means to get point A to point B, what is my angle of rotation? 120 degrees. Okay, that's not done though yet. Which way is it rotating? Counterclockwise. So when you answer these questions, okay, you need to pay attention to 2 things. You need to be able to divide it into segments, okay? Even if I have it on a grid here, like this is still 360 degrees, okay? Because I can put my grid within a circle. I can always do that. So I'm always dealing with 360 degrees. Does that make sense? And then I'm dividing it out according to how many segments I have. So then you need to pay attention to what way my arrow is facing to know if it's counterclockwise or if it is clockwise. Okay? So your answer will always have a degree sign and it will say counterclockwise or clockwise when it's asking you what is the angle of rotation. Does that make sense? Okay? Now, here it says rotate the point -4, 1. So I'm going to draw -4, 1. It's right there. And they want us to rotate this point 180 degrees about the origin. So if this is my origin, right? I draw my little line. If I'm going 180 degrees, what quadrant am I going to end up in? Which one? 4. I'm going to end up in quadrant 4. Okay? Because each of these quadrants are 90 degrees. So whether I go this way or whether I go this way, I still end up in quadrant 4 in this case. Okay? So I want to rotate this point, -4, 1, about the origin. Now, because it doesn't tell me a specific direction, I go clockwise. Okay? If it doesn't tell you, if it doesn't specify, you go clockwise. So I'm going to go clockwise. So this is going to have to rotate from here 180 degrees into that quadrant. Okay? If I am rotating 180 degrees, okay, you take the opposite of each coordinate, which means this should say this. Okay, you're taking the opposite of each coordinate. So my coordinates right now are -4, 1. What are my new set of coordinates then? What? 4, -1. 4, -1. So my point is going to get graphed at 4, -1. Okay? And that is 180 degrees. Does that almost, I mean, if my graph was perfect, that would be a straight line. You get what I'm saying? Okay, so I just take the opposite of what these are. Can you handle that for 180? Whether it's 180 degrees clockwise or counterclockwise, I use the same rule. Okay, clockwise and counterclockwise, I just take the opposite. This here is a whole triangle. I have 3 sets of points. And it wants me to rotate this, the figure 90 degrees clockwise. So I'm going that way, 90 degrees clockwise. Okay? When I do 90 degrees clockwise, what is my rule? What happens to my points? You switch them and what? And the x becomes the negative or the opposite of what it was. Okay? So point A, instead of being negative 3, 2, my mapped point A is going to be what? 2, 3. Yes, 2, 3. I switched that. What would my mapped B be? That's going to be B. What would B be? What? 4, 3. Okay? And what is mapped C going to come out to be? 4, 7. So when I rotate this 90 degrees, that means it's going to end in this quadrant. Are all those points in quadrant 1? Good. So I go 4, 7. That's mapped C. I go 4, 3. That's mapped B. And I go 2, 3. And that's mapped A. So my triangle, if this was perfect, yep, it would look like this. So this is a 90 degrees clockwise rotation. Does that make sense? You think you can handle that? Okay. So in the book, they give you this little chart to help you remember all the rules and just to put them in one nice little area. So it goes like this. Rotation. And then it says original point. And then it calls it the image point or the map point, whichever one, the image point. Okay? So it goes like this. And then it says 90 degrees clockwise. And we start x, y, and we end up getting y, negative x. Then it is 90 degrees counterclockwise. A lot to fit in a little space, counterclockwise. And it goes, starts at x, y, and it would switch to negative y, x, okay? And then 180 degrees clockwise and counterclockwise. And it is my original points, if they're x, y, then they become opposite of what they are, negative x, negative y. Okay? So, how do you feel about rotation? Any questions about rotation? Anything that needs clarified about rotation? You just want to practice rotation and try it out. Okay, so rotation, especially if it's 90 and 180, I encourage you to just use the rule and apply it